Hello my dear friends, welcome to our program for chemistry, third secondary stage. We have today another session about electrochemistry, but today we have different types of cells. How can we produce the electric energy from the cells? And what are the chemical reactions that happened in these cells and what are the differences between them? This one is very important session. Concentrate with me very well. Let's go to start our session today. Today we have another part about the electrochemistry. We have measurement of the electrode potential. What's meant by electrode? Electrode, it means the half cell, as we see in the last part of this reaction. What is the value of voltage here that produced from these batteries or the cells? Scientists had agreed to use this standard hydrogen electrode. It means She. What's meant by She? She is the symbol of standard hydrogen electrode. So as a standard electrode, by knowing the potential equals 0 volts. Here we have, I need the potential. What's meant by potential here or potential difference here? It means what? It means the type or the amount of electric energy that produced from the two halves of the cell. One of them, if I have She, or if I have standard hydrogen electrode, it means what? It means this one equals 0, so I need to know, or I can measure the other part of this cell to know how many volts that found here. So mister, we have volts. It's produced by what? Produced by the chemical energy or chemical reaction between the metal and its solution in each half of the cell. So here the scientists had agreed to use this one. Which one? Standard hydrogen electrode. Electrode, it means pole. Which one? It is 0. Okay, so 0 volt to measure the other parts. Here we have the part of what? Of the two Daniell cell. So Daniell cell here, it means what? It means two halves of the beakers or two halves of this cell, and we have the salt bridge between them. So here we have the electron here. That's what? That's hydrogen or hydrochloric acid that makes a hydrogen electrode that we measure this one, okay, like this. It contains what? Contains a part of what? A part of the cells here, or a part of platinum that found or dipped in what? In hydrochloric acid to make the hydrogen pool. And we have the other one, we have copper sulfate. And the copper sulfate, we have this metal, it's called copper, and here we have the salt bridge between them to connect between them here, between the two halves of the cell. The blue one is copper sulfate and the other one electron or hydrogen electrode. To make what? To make the hydrogen here to measure 0.34 volts of what? Of the copper electrode here, because this is the hydrogen electrode. Hydrogen electrode, it makes this reaction. Here we have hydrogen. It is very important to know the shape of this electrode. Why? Because we have a tube that measured or that connected to what? Connected to the other part of the cell. And here we have platinum wire inside this tube. And after that we have hydrogen that found. We have a hydrogen current that found here at 1 atmosphere. And we have the platinum electrode also. And after that, the last one in this one or this shape, we have hydrogen gas outlet. Means what? It means bubbles of hydrogen gas. This is the formation of hydrogen electrode to make what? To make the chemical reaction between hydrogen and hydrochloric acid solution that found in this electrode to make the redox reaction. And produce what? Produce bubbles of hydrogen to make losing and gaining electron. In the same time, we have no volts that produced by this one. Why? Because this is the measurement or the standard hydrogen electrode. It's standard here, it means it doesn't make any voltage here, or it doesn't make any solution, or doesn't make any voltage that produced from this chemical reaction between hydrogen that dipped inside HCl 1 molar H positive aqueous solution, it means 1 molar of hydrogen chloride, okay, that make dipping inside, or it contains what? Contains the hydrogen inside the hydrochloric acid. Here we have the platinum electrode here in the second part to make what? To make losing of the electrons from this electrode to change it, the ions, to change the hydrogen into ions. And we have the hydrogen, okay, that makes what? That makes gaining electron to change it into hydrogen molecules again. This one is the hydrogen electrode or standard hydrogen electrode. It's called She. I use it to make what? To make measurement for another voltage or another amount of electric energy from what? From the other metals that dipped inside another solution of these metals. After that, we have this shape. So the shape here, we have the voltage. Here it is a voltmeter, and here we have the metal, or metal here it means M, and we have metal positive. Positive, it means metal lose electrons and make oxidation reduction. You are right. So here we have the oxidation that happened at anode. Excellent. We have here the anode here that makes losing electron. And the other part, we have hydrogen electrode. It means what? We have a platinum surface or a platinum piece that connected to the tube that contains the hydrogen. And all of this system, okay, that dipped inside what? Inside a part of hydrogen current or a compound that has hydrogen. Which compound that has hydrogen here? I need an acid. An acid here like hydrochloric acid, sulfuric acid, any one of them. Because here we have the ions that found here, a hydrogen ion and another ions of this acid. What's happened after that? Here in this part, in the left hand side, we have metal change into positive metal ion to what? And by losing electrons. And after that, we have the second part. We have H positive plus negative electron and change it into half H2. It's a molecule of hydrogen. It's half. Here I need the balance of each one of them in a right way, because it is very important to know the amount of electric energy that produced from 1 mole or half mole or 3 moles or any number of moles here. Between them, we have another one or the salt bridge between them to make the connection of electric energy. It's a salt, NaCl solution, KCl solution to connect between them without enter the chemical reaction between any one of them. So here, this is the shape of the measurement or the experiment to make the measurement of metal voltage here. After that, standard hydrogen electrode consists of, this is the formation of each one of this one. So platinum sheet, it's 1 centimeter square, covered by the layer of a black spongy platinum. Black spongy platinum, it means a layer that found on the platinum to what? To prevent the reaction between them. And after that, so here the flow of hydrogen gas, that constant pressure of 1 atmosphere. This is the second part of She or standard hydrogen electrode. So after that, a flow of hydrogen gas connect in the pressure in 1 atmosphere again. So after this one, strong acid 1 molar. 1 molar, it means what? It means very concentrated one. It's revise this one with me. 1 molar, it means what? It means 1 mole of HCl that dissolve in 1 liter of water. Right, excellent, thank you. So here this is the very concentrated one, which the platinum sheet is dipped inside. Why we have a concentrated one? To start the reaction. Platinum, it doesn't make any reaction because it is inactive metal. I use it for this one, for this property. And we have the hydrogen help us to make what? To make the reaction. So here the strong acid is 1 molar concentrated, which the platinum sheet is dipped inside. After that, we have the equation. It is very important one. This equation, I have what? Platinum plus hydrogen in 1 atmosphere that dipped in what? In the 2 moles or 2 molar hydrogen chloride, for example, or hydrogen sulfate, for example, any one of these acids. So this is the equation of what? The equation of this half of cell. We have one half here, it's platinum Pt plus hydrogen, one atom, okay, that dipped inside it means this slash. Dipped inside what? Inside a solution of hydrogen. The meaning of solution of hydrogen here, it means an acid, concentrated acid that has how many molar? Yes, 1 molar, thank you. We have what? We have the hydrogen electrode. It's one of this hydrogen that found in what? In platinum, and we have water, or here we have the acid, okay, and here we have voltmeter here. This voltmeter, it makes what? It makes the reaction, okay, Zn plus Zn positive 2 to make 2 electrons here. So here this is the reaction between them, and the voltmeter, it moves to right and left. Why? To try to measure how many voltage here. So the voltage here, it means what? It means EMF of this electrode that found in the zinc, it's 0.76 volts, okay, and we have the reaction between them. It's very important to know this. We have the copper sulfate or copper nitrate or any one of the salt solutions here. I can measure this one like this, okay. So here we have the hydrogen electrode to make measurement for what? For the copper electrode. Copper electrode, it makes positive 0.34 volts to make what? To produce electric energy. This is the amount of electric energy that produced from each one of them. So here we have the equations also, as we said before. So here we have two parts like this. We have Daniell cell again to make the total EMF of what? Of each one of them. It's connect to each one of them. That makes what? That makes 1 volt. So here 1 volt, it comes out from what? Comes out from 0.34 volt and 0.76 volts, okay, to make what? To make 1 volt for Daniell cell like this. So the redox reaction, again, we have an exercise. The redox reaction, one substance that reduced here in one substance is what? Is which one of these things? Oxidized or lost? Again, we have the redox reaction. One substance is reduced, so the second one is oxidized. Here in the hydrogen electrode, so we have here, this is the reaction between the hydrogen ions and what? And the hydrogen current, or dissolve this one. So we have nothing here to make redox reaction, but it is a measurement part. So the oxidation and the reduction always takes place in the same time or different times. We have in the same time, because each one of them or both of them, they take place between what? Between the chemical reaction, oxidation and reduction always takes place. So in the same time, in the same reaction, if I have oxidation, I have reduction. If I have reduction, I have oxidation. So it is about this one. So oxidation means what? The addition of what? Oxygen or hydrogen. Oxidation is very easy to make addition of oxygen or losing of electron. But the reduction, it has what? It had this shape. So it gains or lose electron. The reduction, it gaining electron. So the reaction, it's losing electron and increase the amount of oxygen to the compound, to the element, any one of them. If an atom, number 3, we have an atom gains electron, it becomes which one? Negative ion. Thank you. This is very important to know. This is small information or very little information about what? About your exam. It's very easy to know this. Okay, so it is an atom. Number here, we have an atom that gains electrons, it becomes positive ion. It's this atom. Which one gain or lose to becomes positive? So it is loses the electron here. After that, number 4, ABC. So here the magnesium react with oxygen. Magnesium is what? Oxidized or reduced? It's only oxidized. Really, it's oxidized. Why? Because an oxygen is reduced. Magnesium here, gain or lose? Loses electrons from the positive magnesium ion to form magnesium ions. And after that, we have oxygen gain electron to form what? To form negative oxygen ion. So this is the about a revision or quickly revision for redox reaction in this case. Electromotive series. It means what? It is a very important part of our chapter. To know what? To know the amount of electric energy that produced from what? From the metals. All of them are metals. We have no non-metals here. But here we have what? We have the electromotive series. It's very long one. To make what? Scientists had measured the standard hydrogen electrode. It's E0. Potential is E0. It means E0. The energy or electric energy that produced from the She or the standard hydrogen electrode, it's equal 0 for all metals and non-metals. So the half cell relative to She. So if I need to know how many volts of each element or each metal, I must dip this one or make it dipped inside a solution of its compound or its salt, for example, sodium in sodium salt solution. And we have, for example, copper, it's copper sulfate solution, for example. I have one rod for the copper and dip it inside. To measure what? And connect to She, okay, or standard hydrogen electrode to make what? To make the measurement by voltmeter. So the definition of this electromotive force or electromotive series. This is electrodes. It's an arrangement of element descendingly. Concentrate with me. Descendingly. It means from the strongest one or the highest one to the lowest one. Descendingly. According to their oxidation potential with the hydrogen. Oxidation potential, it means the amount of voltage that produced from oxidation reaction or from losing electrons like this. So we have one type of measurement or one method to make measurement of each one of them. Arrangement of elements descendingly according to their oxidation potential with hydrogen. After that, we have another definition. It's the arrangement of elements ascendingly. It's the opposite of each one of them. Okay? Ascendingly according to their reduction potential with hydrogen. Again, concentrate with me in this one again. It's an arrangement. This series or electromotive series, it's an arrangement of elements descendingly according to their oxidation potential with hydrogen. It's very important to know this one. So after that, we have another definition, or it's an arrangement of elements. Which elements? We have metals and the hydrogen ascendingly according to their reduction potential with hydrogen. So after that, we have, this is the two definitions of this one. In this case, we have the She or hydrogen electrode. So this is the reaction of this electrode. It's positive ion plus one electron that change into hydrogen ion. So here we have no any of the potential that happened in this case or in this one. Why? Because the hydrogen, it loses one electron, change to one atom. So we have no voltage that produced from this one, as it is the standard hydrogen electrode. So this one, it is the half of the cells of Daniell cell that, or measurement cell for any of the elements or metals that found beside this hydrogen electrode as we illustrated. Okay. After that, we have, there are some facts about the series. What are these facts here? The first one, we have the most low positive oxidation potential element which lie before the hydrogen in this series, their oxidation state. So here, this is the most of low positive oxidation potential after hydrogen. Why? Because which lies before hydrogen in what? In the series, their oxidation states, okay, according to their oxidation states. After that, the most positive oxidation potential elements which lie before hydrogen are considered as a strong reducing agent. Not be confused. Don't be confused. Again, we have the most positive oxidation. If I have positive 3 volt or 1 volt positive charge, the positive oxidation potential elements which lie before hydrogen are considered as a strong reducing agent. Why? Because it is the metal agent. It means what? It is a type of elements, okay, that, or the elements or metal that makes reduction, strong reducing agent. This is what? This is the which lie before hydrogen. Okay, and after that we have they oxidized easily by losing electron. During what? During the chemical reaction, such as here we have Zn change into positive 2 ions and lose 2 electrons. Why? Because this makes what? It makes oxidation. It's very easy to make this equation. This is the half equation of zinc in any type of elements or any type of cells that found here. We have oxidized easily by using electron during the chemical reaction, such as Zn give us losing electron or losing 2 electron and change into Zn positive 2. And here we have another one. For example, we have sodium, 0 charge. It is an atom of sodium. Change into what? Change into 1 electron or lose 1 electron and change into Na positive 1. It means the ions or positive ion of sodium. It means oxidation, oxidized easily because it's found before what? Before hydrogen. As we have, they are more active than hydrogen. Like what? Like electrochemical series or chemical activity series. So this is the same things that happened or that compared between these two series. Okay, so the oxidized easily by losing electron during the chemical reaction, such as zinc or sodium or aluminum or anything like this of these metals that are more active than hydrogen. All elements again lie after hydrogen can replace hydrogen from its compounds, such as what? Such as this one, Fe, for example iron that found here, and plus 2 HCl, FeCl2 plus H2. So it is very important to know these points here about this series. So the element lied after hydrogen. So the first part is before hydrogen. Here after hydrogen can replace hydrogen from what? From its compounds such as Fe plus 2 HCl give us FeCl2 iron chloride 2 plus hydrogen that evolved from this reaction. Why? Because this iron is more active than hydrogen, but it's in the same time it's less active than sodium and zinc and so on like this. Okay, here we have what? We have Zn and copper. So here this is the type of Daniell cell again, and here we have the potential between them according to what? According to the chemical activity series or potential series. So here Zn, it's a part or a rod of zinc that dipped inside ZnSO4, and after that in the second part we have copper. This copper it's dipped in CuSO4, it's copper sulfate solution. So the voltage here it is 1.1. Why? Because the copper here in galvanic cell, it means what? It means the positive pole, and here the negative pole is zinc. So after that, the negative pole that produce electrons to the voltage or to the voltmeter to measure it, and the electron that pass through the wires to what? To the copper, to make what? To make another part or to measure the voltage of this cell, galvanic cell. So here this is the positive or the summation between them, it's 1.1. Here we have the difference between each one of them, Zn and copper, the difference or the potential difference here in this cell, it's called what? It's 1.1. Why? Because here positive 76, okay, plus what? Plus 34, 0.34, it's 1.1. So here this is the total amount of voltage between these two parts of the cell or two halves of the galvanic cell. If I put here the zinc metal, okay, in this case, so here we have the zinc, it's dipped inside the zinc sulfate or copper sulfate or anything of this solution, it makes what? It makes the reaction between them. So here the Z react with copper aqueous solution to form Zn aqueous solution and the copper that make precipitation on each one of them. So here the Daniell cell or galvanic cell, here we have the positive pole and negative pole in each parts. Here we have the copper, and here the last part we have zinc. Zinc and copper, the most famous one in this case of galvanic cell or Daniell cell. So the copper here, it makes the reduction, and the zinc, it makes oxidation. And here we have the salt bridge between them, it's Na2SO4 aqueous solution. So between them we have, this is the reaction, and the light or the lamp is light up. Why? Because we have 1.1 volt of this Daniell cell or galvanic cell. Why? Because the positive pole of copper and the zinc negative pole of this zinc, that makes what? That makes reaction between them. So here in the first part we have the zinc that dipped inside this one, the ions of zinc that dissolve in the solution, and the copper positive 2 that make precipitation on the copper to move what? To move the electrons inside. So the copper positive and zinc is negative. This the zinc is anode in this case, and we have the copper, it's cathode in this case. Mister, we have anode is negative. Yes, in the galvanic cell we have the opposite. So we must know, or we should study this part very well. Which one is cathode, which one is anode? Why? Because we have big difference between these types of cell, galvanic cell, Daniell cell, and we have the types of the cell after that. So the anode, it produces the electrons to what? To the positive one, to the cathode. So here, at cathode we have what? We have reduction. At anode we have oxidation, because the zinc loses electrons. My friends, I hope to enjoy your time with me. It's a very important one to know this information about the types of the cell and the reaction. Don't forget the half equation. Don't forget oxidation and reduction. This is the basics information of this electrochemistry. Till we meet again in another session about this chapter. Till we meet again, thank you and goodbye everybody.